Welcome to EDU World Space.
So due to things we're given in question 70 into this figure here on the left side, so we have a layer of benzene with an index of refraction of 1.5 that's sitting on top of a layer of water, and the depth of the benzene is 4.2 centimeters, whereas the depth of the water is 5.7 centimeters. And we're given the indices of refraction of benzene and water. And so, since they're sitting on top of each other, there is an interface that's formed here. There's another interface that's formed between air and benzene, which will come into play a little bit later. But the question that we're asked is, what is the apparent depth of the bottom of the water when you're viewing it at normal incidence from the top of the benzene layer? So, what we need to figure out or actually take into consideration is that at this interface, at the benzene water interface, there's going to be an apparent depth from the bottom of the benzene to the bottom of the water. There's going to be an image that will give one apparent depth. And then when you look at the top layer, that image is going to be the object, the new object. So then you get a second image. So the image from the benzene water interface will be the object for the benzene air interface, and that will form a new image. So let's first find the image that we get from the benzene water interface. So let's call this distance S1. That's our object distance for the benzene water interface, and we'll use equation 34.13, which tells us that NA over S plus NB over S prime is equal to 0. Let's call this right away S1 and S1 prime. And the idea is to find the image that we get, or the apparent depth, right, which is the same thing as the image for this benzene water interface. And let's note that Na is for water, and Nb is benzene. Write those over here. So Na is water, and Nb is the index of benzene. Okay. So if we solve this for S1 primed is minus S Nb over Na. And we can just plug in because we know S1 is 5.7, NB is 1.5, Na is 1.33. So this gives me minus 5.70 centimeters. And then I have 1.5 divided by 1.33. So S1 primed is equal to minus 6.43 centimeters. Okay, so that's the apparent depth of the bottom of the water when viewed from the benzene water interface, or when viewed from the bottom of the benzene layer. So now this S1 primed, kind of running out of space. Let's put it somewhere here. So this will be S1 primed, which we know is equal to 6. It has a magnitude of 6.43 centimeters. Okay, so it appears to be deeper than than it actually is here. And now we want to, so this, we want to find the apparent depth when we're viewing from the top. So our new object distance then is from the top of the benzene layer to the apparent depth here. So that's 5.7 centimeters plus this, that's a 4.2 centimeters plus S1 prime, which is 6.43. And that gives me 10.63 centimeters. So this, let's call this S2. Okay. And now we use the very same equation to find the image, or S2 primed, which will be the apparent depth of the bottom of the water when viewed from the top of the benzene layer, which is at the benzene air interface. So now my new, and so I have Na over S2 plus Nb over S2 primed. And that's equal to 0. And here, now I have Nb is air, so that's 1, and Na is benzene. So I have and S2, we know S2 is 10.63 centimeters. So if I use the same equation here, but instead replace S1 by S2, then I have S2 primed is equal to S2 times NB over NA. Keep in mind we have new values for NB and NA. So then I have minus, sorry, I'm missing a negative sign, 10.63 centimeters times NB, which is 1, divided by 1.5, which gives me negative 7.09 centimeters. So that is the apparent depth of the bottom of the water when viewed at normal incidence from the top of the benzene layer.